Okay, we review the determinant. What is determinant? We use recursive definition for determinant. The second order determinant, or the determinant of order 2, that we can write as A, B, C, D. The determinant is absolute difference with matrix. The determinant is a number. A determinant is a number, that is AD minus BC. And for A3, the order of 3, that is A11, A12, A13, A21, A22. Okay, the determinant sometimes we write as A in two vertical lines, or the determinant of A. If A is a matrix, we write as the determinant of A. The three-order determinant, A32, A33. For order of 3 or higher order determinant, we use determinant expansion. That is A11 times negative 1, 1 plus 1. The indices of its row, its location of its row, and its location of its column. And A we could write as A22, A23, A32, A33 plus A12, negative 1, 1 plus 1. That is A21, A23, A31, A33 plus A13, negative 1. That's 1 plus 2. That's 1 plus 3. That is A21, A21, A22, A31, A32. What this means, that is A11, negative 1, 1 plus 1. All these three determinant is actually the original determinant cancelled the number, the row and the column, of this number located A13, A21, A22, A23, A31, A32, A33 plus A. Actually, because this is A11, so we cancelled the first row and the first column. The remaining determinant. Okay, the A12, negative 1, 1 plus 2. That is A11, A12, A13, A21, A22, A23, A31, A32, A33. We cancelled the column and the row and the column of A12 plus A13, negative 1, 1 plus 3. That's A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, we cancelled the A13, the row and the column of the A13. Okay, that's the definition of A3 and A4, and any other order can be write as sigma A I J and Aij as j from 1 to n. The Aij is -1 I plus j times Cij. The Cij is equals the A, which is A cancelled ith row and jth column, which is A when A cancelled ith row and jth column, the remaining determinant. This is expansion by ith, because the ith does not change here in the summation, by ith row. Actually, the determinant can be expansion by any row or any column. That's the definition of the, or actually we can write it as I from 1 to n. That's Aij for any j. The j for any j is the same thing. That's the definition of the determinant. There's many properties of the determinant. We only collect the most important properties here. The first one is when we exchange or interchange two rows, the determinant changes sign. When we interchange or exchange two rows, then the determinant changes sign. That's from positive to negative, or from negative to positive. Any common factor of one row or column can be moved outside. Can be moved out the determinant. That means we times the determinant by this number and divide the row by the same number. This is different with matrix. The row reduction for matrix, if we divide one row or column by divide by one row by a number, and the matrix is equivalent. The two matrices are equivalent, but for determinant, if one row divided by one number, it should be multiplied the same number outside. The third property that is multiply one row or column. Multiply one row or column by a scalar and then add to another row or column. The determinant does not change. Or column by a scalar and then add to another row or column. The determinant does not change. These three properties are used to compute the determinant, and these properties is very similar to row reduction, but for determinant, any operation on rows can be used for columns. That is for determinant. The row and the column are have the same the same importance. Now let's use these properties and the definition of the determinant to evaluate the determinant. Okay, first actually we use the operation, row operation, or these three operations are called elementary operation. Elementary operation. We use elementary operation to compute the determinant. Now the determinant A, or sometimes we write as this, as 1, 2, 3, 4, and 1, 3, 4, 1, 1, 4, 1, 2, and 1, 2, 3. Use row operation, elementary operation. Actually, we use the method is used to reduce the order. Reduce the order. The method of reduce the order. What is reduce the order? First, we use the elementary operation to reduce the one column or one row to be all the members of one column to be 0 except 1. For this one, each row subtract the first row, then the first column to be all 0 except for the first one. The second row subtract the first row, that is 1, 1, negative 3. And here is 2, negative 2, negative 2. And here is negative 1, negative 1, negative 1. Okay, that's 1, 2, 3, 4. 0, 1, 1, negative 3. Actually, the okay, sorry. Because the first row of the first column are all 0 except 1, we expand the determinant by the first column. So that is 1 times -1, 1 plus 1. And the remaining determinant is 1, 1, -3, 2, -2, -2, -1, -1, -1. And the third row has common factor -1. So we times -1 or divide by -1 for okay, and that is means the common factor of the third row can be moved outside. That is, we move -1 outside, then the third row becomes 1, 1, 1, and there's 1, 1, -3, and 2, -2, -2, and the second row has common factor 2, so we move to 2 outside. 1, 1, -3. That is 1, -1, -1, 1, 1, 1. That is -2, and we use elementary row operation. The second row subtract the first row. That is 0, -2, 2, 0, 0, 4. And then we expand by the third row. That is 4. The 4 is at the third row and third column. And the remaining is the 1, 1, 0, -2. By the definition of determinant of order 2, here is -8, and times -2, that is 16. That's the method of reduce the order. We reduce one column or one row to be all 0 except one member, and expand the determinant in terms of that row or column, and then the order of the determinant is reduced. Okay, that's the example for computing the determinant. Let's see another example. The determinant of A, that is 1, 1, 1, 1, 1, -1, 1, 1, 1, 1, -1, 1, 1, 1, 1, -1. First, we subtract each row subtract the first row. 0, -2, 0, 0, 0, 0, -2, 0, 0, 0, 0, -2. Expand by the first row, we have -2, 0, 0, 0, -2, 0, 0, 0, -2. Because this is diagonal determinant, we just multiply the number in the diagonal at the diagonal line. So that is -8. Otherwise, we can expand the determinant row by row, and we got the result is -8. That's the computation for determinant.